Okay, I think we're on the air.
All right, great. Thank you everybody for joining today. This is the Q1 2021 Shardus quarterly update. So this time it's going to be a little bit different than previously. Um, we've been working really hard to get, but we've been having some difficulties, and so we're gonna, show you the demo anyways. There's a very high chance it won't work, but we did have one run where it did work, so there's also a really small probability that the demo will work. But we're gonna just get this demo started because it's going to be running for quite a while. So I'll have Amir switch on his screen so you can see the nodes. So basically, what we're, in the last quarterly event, Amir, go ahead and get your screen going, and then you can maybe go ahead and try to start uh, the network spam as well. So in the last quarterly event, we demonstrated linear scaling, where we showed a network of 20 nodes, and we hit it with I think it was 100 transactions per second, and that network was able to handle it with 20 nodes. But then when we increased the transactions per second to like 150, then the network was not able to handle it. It was starting to reject transactions. Then we had another network, and that network had 200 nodes in it. And when we hit that network with 150 transactions per second, that handled it really easily. And in fact, we were able to push that network up to 1,000 transactions per second, and it managed to handle that. And only at about like 1,200 transactions per second, then it started dropping some transactions. So what that showed was that as you increase the nodes in your network, the transaction throughput that your network is able to handle increases. Now, this quarter, what we want to demonstrate is that the network can auto scale, meaning that the network can recognize that the load is increasing and then automatically allow more nodes to join the network and grow the network. And then eventually, like if the traffic drops off and the transactions per second starts to get less, then the network shrinks back down, letting some nodes out of the network and scaling down. So that's what we've been working on, and it's really a very tough problem, um, but we're going to see if it works this on this demo run or not. But this kind of reminds me a lot of like if you've ever watched the SpaceX launches, and the rocket blows up on the launch pad. Well, you're going to see this Shardus. Most likely, there's a high chance that you're going to see a Shardus version of a rocket blowing up on the launch pad today. So just kind of give you the heads up on that. But yeah, so we were up until like 6 a.m. last night, and trying to get this working. And throughout the quarter, we've been knocking out lots of bugs related to syncing and scaling and things like that. And what happens is that these bugs kind of appear like one after another. So like you don't see the later bugs until you like knock out the bug that's visible now. And once you get that one fixed, then you're able to push the system a little harder, and then you see some other bug, pop up, and then now you have to, kind of work that one out. And doing this on AWS, each iteration takes a long time to try it, and then fetch the logs, analyze those logs, find out what could be the issue, and then go fix that, and then run another test, and so forth. So it takes quite a while to go through those iterations. And last night, what happened was, at the last minute, when we thought we had found everything, and cleared out all the bugs, a new bug popped up that we hadn't seen before, where our node list was on some nodes being different than other nodes. And so we traced that down, and we weren't able to reproduce it locally, to try to work on that problem. But it was a really edge case situation where we have a node that's already in the network getting refreshed, and another node thinking that node was lost, but then that node that's being marked as lost refuting it, while at the same time a new node is syncing and sees all these transactions and gets confused and ends up with a different node list than the rest of the nodes in the network. So it's a really strange edge case scenario, but it seems to happen a lot on AWS, but it doesn't happen when we run this locally. So we have 40 nodes started there on AWS. That's what you're seeing on Amir's screen there. And there's they're currently syncing up. So the nodes that are gray are kind of not part of the network. They're waiting to join. The nodes that are green have already joined the network and synced up. The node that's yellow is still syncing up its state to what the other nodes have. So, one of the things with Shardus is that we need our nodes to get synced up on to the state of other nodes within, a minute or two. Now, typically, if you've worked with any kind of blockchain, you know that it, to catch up, let's say on the Bitcoin network right now, you would need to be running your computer for a couple of days for it to catch up to the current state of the Bitcoin network. And Ethereum is even worse. You probably run your node for a week or two before it actually catches up to the current state. So with Shardus, we actually want lots of small nodes to be able to join the network. And nodes don't actually hold all of that, transaction history. They push that off to archive servers. But what nodes do hold is the current account states of all the different accounts that are in your ledger. And we've designed algorithms where the nodes can get synced up on that current state really, really fast in a trustless manner. And so that's one of the things that makes Shardus unique and different is that we have this super fast syncing process. Now, our goals with Shardus is really to provide a distributed ledger that can offer true linear scaling while also maintaining the highest level of decentralization possible. And while doing this, we also have to keep in mind that we want to keep the highest level of security, make the system so that it's really easy for developers, and also we're designing it so that it's energy efficient and doesn't use things like proof of work. Now, what do I mean by true linear scaling? Well, basically, okay, Amr, you switched your screen there.
No, just pulled up the chart because it seems like the 10 nodes are in and we're going to start the auto-scaling soon.
Oh, okay, great. Yeah, okay. So we've got the 10 nodes already in the network. And so what we're going to do is start hitting the network with a lot of transactions per second. I think we're going to go at like 50 transactions per second. And then we should start seeing the network start to allow more nodes to join the network to reduce the traffic or the load that the network sees. Um, and so go ahead, Amr, go ahead, start hitting the network with the transactions.
With the spam, all right, sounds good. Let me get the spam command primed and then I'll get it going.
So if you look at the top right corner, you see like it says desired 10. So currently the network only wants 10 nodes to be in the network because, well, there's no traffic going on. So those nodes could easily handle a few transactions coming in every second. But if we start really hitting it, then we should see that desired number start to go up.
All right, spam's ready. Let me go ahead and start it.
Yep.
50 TPS or
Yeah, go
basically
ahead
until
with
it grows.
yeah, go ahead with 50 TPS. Okay, there. So the red dots that you see coming in, those are representatives of the transactions, and those are coming into the nodes. They're passing the transactions around to the different nodes in the network, so that every node eventually will see every. Well, so in our case, every node doesn't necessarily see every transaction because this network is sharded. So I think the shard level is right now set to just 5 nodes, right? Amr?
Yeah, shard consensus size is set to 5, so yep,
Right. Okay.
shard size is 5.
Yeah. So there's about 5 nodes in the shard, and so um, as we add more nodes, dynamically it'll create more shards, and so uh, every transaction doesn't actually end up being seen by every node. So if we okay, if you want to go back to the yeah, Amr, you might not want to do that. You might want to switch off back and forth because it's kind of going to make
This part cover that area.
yeah. So then it like neither of those is really easy to see. So we'll just switch between the two as needed.
All right.
But yeah, can you blow up the thing so that it like just make them like tabs and then have have each window be bigger.
Oops.
But yeah, so this white chart that you see here shows us a graph of how many nodes are in the network, and then uh, the the red line is the amount of load that the network is seeing, and eventually, like as that load goes up, the network wants more nodes to join the network, and as more nodes join the network, that brings the load back down. And so you eventually get to a point where the network doesn't want more nodes to join the network. So Amr, if you switch back to the monitor screen. Okay, so since we're hitting the network with transactions, you can see that the desired count has now gone up to 40. So the network wants 40 nodes to join the network. And we just had 5 more nodes join. Um, they, they were just now syncing, and then they went active. And pretty soon we should see some more nodes being allowed into the network, and then they'll start syncing. So you should see them as being yellow nodes. And once those are synced, then we'll have like probably 20 active nodes. So currently the number of active nodes is 15. And if you look at the network load down at the bottom left, that's currently at like 0.27. And the network is trying to maintain a load below 0.2. And when it goes above that, then it knows that it should grow the network and let more nodes in. Now, also, if you were to hit this network with a huge amount of transactions, what the network does is it tries to process as many transactions as it can. But if it sees that the load is getting really high, then it'll start to actually reject some transactions randomly and not even accept them. And so your client would see a message like try again, try to submit your request again, kind of a message. And so you would wait a little while and then submit your transaction. And then at a later time, then when the network doesn't have as much load, then the transaction might go through. Okay, so if we switch back over to the network graph, you can see that as nodes have been joining, this red line is starting to drop a little bit. So the really light gray line, Amr, you want to kind of point out that line?
Yeah, this one right here.
Right. So that one represents how many nodes are in the network. You can see that at first it was like 10 nodes, and then it jumped up to 15 nodes. And when it did that, the red line started to go down. And now if we switch back over to the monitor client, you can see that there's some more nodes that are syncing up. They haven't gone active yet, so they're not really contributing to processing the transactions. But right now they're talking to the other nodes and getting the state data and getting themselves synchronized to the network so that they can participate. Okay, so we had 3 of those go active, and there's still 2 that are syncing. So pretty soon we should have about 20 nodes that are active in the network. So yeah, there we go. So we've got 20 nodes active in the network. And Amr, if you switch back to the chart, we should probably see the load starting to go down now from due to those additional nodes. So what I was saying is that the goals of Shardus is we want to achieve true linear scaling while maintaining the highest level of decentralization. Now, to achieve true linear scaling, it of course you need a sharded network so that every node doesn't have to process every transaction. But you still won't be able to get true linear scaling unless you're sharding dynamically, which basically means that every single node that joins the network actually contributes to the number of shards kind of increasing. And we're, with Shardus, we're using what we call dynamic sharding, where there aren't like fixed shard boundaries, and they're not static, because a lot of different projects that are out there that are doing sharding, they're using static sharding, where the shards are predefined, and the bounds can't be changed, and you don't create another shard until you've had a large number of nodes join, and then you can create another shard. So you need, like, say if your shard size is like 20 nodes, then you would need 20 more nodes to join the network before another shard could be created. But with Shardus, we're doing dynamic sharding, so it's as if we've got more shards with every node that joins the network, and so that allows for like true linear scaling. And we really wanted to have this because we want a network where it's permissionless, where nodes can just join and leave, without an authority saying, oh, we need 20 nodes to be there before we can let them all in, or something like that. So we're trying to shoot for a goal where a lot of different nodes can just be coming and going, and contributing to the network. And you really need this in order to have a high level of decentralization. Okay, so we've got the 20 nodes in there now.
Hey, Omar, I just wanted to point out that the yellow line on the graph shows our rejection rate, and it's nearly zero as the other nodes have helped out.
Yeah, that's right. So the yellow line is showing how many transactions are getting rejected. And as you can see, when more nodes join the network, that number of transactions that the network is rejecting steadily goes down. And now it's almost like zero transactions are getting rejected.
Another
Now,
thing that I wanted to point out was the green line. So that's the internal load, which is the number of messages passed between the nodes themselves. That's been like following the trend as well, really well, of going down
okay.
as the nodes increase.
Now, I'm wondering why the load kind of went up a little bit after we got up to 25 nodes. That's kind of odd. I haven't
Yeah,
seen
it
that
seems to
before.
spike every time like a new set of nodes comes into the network and then drops after that.
Huh,
So like
It's
interesting.
it's doing a little bit of partition fix-up work as they just joined the network.
Okay, gotcha. So that increases the load while nodes are talking to each other to grab some partitions, and trying to repair partitions, I guess.
Yeah.
All right, cool. Okay, and then now we've got 5 more nodes syncing up. So yeah, basically, as more nodes. So Amr, what's our total load at right now? Just, let me see that, because I don't want it to fall below 0.2, because then the network will start wanting to downsize. So just
it's
kind of
at
keep, yeah, it's like
0.220.
right. So just kind of keep an eye on that, because if that falls below 0.2, then the network will start downsizing already.
Mm-hmm.
So, but yeah, so what we're trying to shoot for is a high level of decentralization while having linear scaling. And so if you look at the current state of blockchain and the different projects that are out there and what's happening, of course, when Bitcoin started, it really didn't care about scaling at all. It was just a great demonstration that we could achieve a trustless network of a lot of different nodes, and these nodes could come to consensus on what transactions are have been processed, and do that without needing any kind of a central authority to decide which nodes are in the network. So that was a big achievement, and it really wasn't trying to go for a high transaction throughput. So Bitcoin, I think currently gets about maybe 4 or 5 transactions per second. Now, when Bitcoin first started, it had thousands of real autonomous nodes in the network, all of them trying to really create a block. But as Bitcoin got more popular, what started to happen is your chances of creating a block started to go down more and more, such that you may, like, once in 5 years create one block if you kept your computer running that long. So because of that, what people ended up doing was creating these mining pools where they just pooled their computing resources together and tried to create a block that way. And once a block was created, then the block reward would be shared by everyone that was contributing to the pool. And so that made it such that I would maybe not get the full block reward, but I could get a partial block reward if our pool found a block, because it would be shared among everybody that was in the pool. And so what that eventually started to do was reduce the amount of decentralization, where the entities or companies that were running these pools were the ones deciding what transactions would actually go into the block, and everybody else is just contributing hashing power to help find basically the winning number that would create the winning block. And so all those other computers that were just providing hashing power had no say in what transactions would go into the block. And so you're basically losing that decentralization. And we're now to the point where I think there's only about like less than 12 really big miners out there, and those miners all know each other, and they go to conferences and together, and so they could really easily collude if they wanted to. And so if there was some account that got blacklisted, for example, then those miners could decide that, hey, any transaction that comes from this account, we're just not going to process it. And so now you don't have that decentralization, right? So now if you think about it, would you want to put your hard-earned money on a network that is controlled by a few entities? Or do you want to put your money on a network where there's thousands of different entities that don't know each other, that are coming and going, and no one of them is able to control fully that network, or decide to say blacklist an account or something like that, right? So this is the key reason why Bitcoin was created, was to allow these type of networks that were completely decentralized and permissionless. And as time is passing, people are kind of not giving too much importance to decentralization, and so over time, we've had other networks come up where Ethereum has shown that you don't just have to be do coin transfers. You can actually pretty much do anything that you want on a blockchain. So now, we can create smart contracts that allow our money to be completely programmable, right? So that allows you to do things like, something like a Kickstarter, for example, right? Like a whole bunch of people can contribute money to a fund. If that total contribution reaches certain threshold, then it goes to the, project. Otherwise, all of that money gets sent back to the original contributors. And that can now happen with just a smart contract. And you don't need this, middleman like Kickstarter to manage that and take a cut out of, what's being transacted there. So those, so that made Ethereum really popular. And, originally, not a lot of people were actually using Ethereum. And so the network was able to handle that kind of traffic. But, as time went on, more and more people started using Ethereum. And now we're to the point where the transaction fees on the Ethereum network are getting so high that it's like maybe $50 to process a transaction, and that's because the Ethereum network is limited to about 12 transactions per second, and everybody that wants to have their transaction go through are now basically competing with each other to bribe the miner to say, hey, I'll pay you more if you put my transaction in the next block. So that's what's going on, and so Ethereum also has lost a lot of the decentralization that it used to have, because it's also proof of work currently, and people are creating mining pools for Ethereum, and there's just a handful of miners that actually create the blocks on the Ethereum network. Now, this has led to a situation where a lot of different new projects have come up that actually want to have a lot more transactions per second. Okay, so I think we've hit our 40 node network. Amr, you want to stop the transactions that are going into the network?
Yeah,
Okay.
I just did.
So
Should be good now.
so it looks like everything went smoothly, but we know that some of these nodes are actually not having the same node list as the other ones. And so once the network is downsizing, that will become an issue, and it may actually cause some of the nodes to crash because it is not able to handle having a different node list than the other nodes in the network. So yeah, on the chart, we can see, if you go back to the chart on the chart, we can see that we're up to 40 nodes. The transactions have dropped off, so we're seeing the load drop down sharply. And so now we should see the desired number of nodes start to go down if you go back to the monitor. So now if you look at the top right corner, the network is now saying that I don't really need this many nodes in the network. I only need 35 nodes. So it kicked out 5 nodes. And so those 5 nodes have respawned and come back in trying to join the network, but the network doesn't want to let them in. And so they're just sitting on the sidelines. Okay, now we just saw one of the nodes in the network go red. Now that's a node that basically crashed because it had a different view of the node list than the rest of the nodes. So this is what we don't want to happen, where a node basically crashes because it, got out of sync with the rest of the network. And so now we're going to see like more nodes do this. But the surviving nodes, we may get in a situation where the surviving nodes are still able to keep that network going, and the nodes that had come in with a different view of the node list, they may all crash, but the network itself could still be processing transactions properly. But still, I mean, we want to get these kind of things fixed up. So, but yeah, so this is the Shardus version of a rocket blowing up on the launch pad. So, but yeah, so going back to the current state of blockchain and what's happening, you know, we're now starting to see a lot of new projects coming up that are trying to build better blockchains, and their main focus is increasing the transaction throughput. Now, most of these projects are doing it by having networks where you just can't add, thousands of nodes to the network. These networks are maybe limited to, say, anywhere from 10 to 100 nodes that can ultimately join the network. And which nodes can join the network is kind of federated by, these nodes having to apply and then get accepted to, become validators or block producers in the network. So it's already kind of giving up decentralization in order to achieve a higher transaction throughput. Now, in terms of what kind of transaction throughput we can get in these networks, it'll vary from, hundreds of transactions per second to some networks that are actually getting about, 10,000 transactions per second. And so that's going to make things look really good. It's it's going to bring down the transaction costs, and people will be able to see their transactions going through really quickly, and everything will look great. But eventually, as those networks get popular, they're also going to hit their upper limit, and then again we're going to run into the same problem that we saw on Ethereum, where these networks, their transaction fees will have to go up because there's only a certain amount of transactions these networks can process. And so when you start to hit those limits, everybody's going to be competing to basically bribe the miners to have them process their transaction first. So that's what you want to avoid. So you really want to design your network from the beginning such that you're not going to hit these upper limits on how many transactions the network can process. You want to design the network such that you can have more nodes join the network, and the upper limit on how many transactions can be processed continues to go up. So that's basically our primary goal with Shardus is to achieve that linear scaling, and doing that while allowing networks that can scale to hundreds and thousands of nodes is really important, because that's what's really needed to maintain the decentralization. So going back to what's happening on the network, looks like we're down to just 10 nodes in the network that are active, but there's 7 nodes that have kind of crashed. And let's see. Now the ones that are active, it looks like their node lists are synchronized, but some of these nodes are catching up and repairing some of their state data and synchronizing it with the others. But yeah, so basically, this is not something that you really want to happen, right? So the network is doing the best that it can to handle the situation, but there are issues elsewhere in our code that we need to fix up. So so this is a demonstration of what we typically see throughout the quarter and what we're working towards fixing so that we can eventually do a kind of a perfect demonstration for you. But this next quarter, we still have a lot of work to do in terms of getting linear scaling working. Although these things kind of sound easy, you can describe what we want to do in a few sentences, but actually implementing this and making it happen is a really, really hard problem. And we're going to continue focusing on it and working on this, and eventually we will achieve it. And once we do, this will be a really kind of the next generation type of a distributed ledger, which I think nobody is even working on doing something like this at all, because everybody's so focused on just kind of building something right now that can work so that they can deploy it. So Shardus, we've been working on this since early 2018. In fact, I actually left my consulting job in 2016 and started focusing on this since then. But yeah, it's really a tough problem, and it's been a lot of work that we've put into it already. But there's still quite a bit to go. But we're hoping that this year we want to get to a stage where the code is working really well. We've done some audits, external audits on the code, and really got it polished and get it to a point where now we can have other projects start using the code to build and launch their networks. Now we do have our own test network for Liberdis that's been running for a couple quarters, and once in a while, those nodes run out of memory and crash, but we're able to launch that network, and everything continues to work. But we're not really to a point that that network is in a state that we feel that it's like production ready. So there's still a lot of work to go, and we're going to keep plowing ahead and getting this built, because I really feel that by building this, we're going to be advancing the state of the art of blockchain and distributed ledger technology faster than what would happen otherwise, and it's going to make new kinds of projects possible that otherwise wouldn't be possible. So yeah, but with that, I will stop the demo, and we can take some questions. I think we have about 15 minutes.
Awesome.
Greg, do you have any questions?
Yep, great
that you see coming?
Yeah, great job, Omar, Amr, Andrew. Really appreciated the presentation. First question is from Zachary Wiles. He asked, I'd like to understand the Shardus intellectual property strategy. Is there any protectable IP? Will other blockchain networks be able to license or reproduce the gains learned here?
Yeah, so basically with Shardus, the model is that we'll create this software, we'll put it out there, it'll be open source, but the license that comes with the software will basically say that if you use this to deploy a public network, then you need to acquire some Shardus tokens and use those tokens to purchase a license token from our smart contract, and that, you know, when you do that, that'll be visible on the blockchain that you've acquired a license for the Shardus software. So any public project that wants to use Shardus, you know, we ask them to buy a license to Shardus. Now, private projects. Oh, I'm sorry. I'm getting this wrong. So that's for the private projects where they buy the Shardus tokens and then get a license, or buy the Shardus tokens and exchange it for a license token. Now, public projects, what they need to do is they just can go ahead and launch their network. But of course, you know, their network will have, you know, some kind of a coin or token on that network. And what they need to do is allow Shardus token holders to be able to claim some coins or tokens on their network. And so that satisfies the condition of, you know, having obtained a license for Shardus. And doing it that way, I think it's beneficial for both the Shardus token holders and also for the project itself, because, you know, when a new project is launching, you want to attract more people to come to your project and your network and become users on that. And by giving Shardus token holders coins on your network, you're incentivizing that as well. So that's kind of the model. Now, we will also be, you know, obtaining you know, patents on some of the technology that we've developed with Shardus, but you know, we want to do those as like defensible patents, just so that somebody else doesn't just copy that same technology and then prevents us from using it. So.
Good response, Omar. Next question comes from an account named Poorcoder. The question is, from our previous quarterly update, we mentioned an open source wallet. Can we provide more information about that? I'm interested.
Yeah. So we're developing a wallet called Coinica. Now, what happened was last quarter we lost some of our developers. A lot of it is related to COVID. You know, one of the developers said he got, like, he's based out of Japan, and he said he got COVID, and then that was the last we heard from him. So we don't really know what happened there. And then another developer, his parents got COVID, and then he had to leave the project to go take care of them, and so forth. So we've had some you know, downsizing, and we haven't been able to work on those projects as much, but we do have those on our roadmap. And you know, like the Coinica wallet, the reason why we're building that is because we really feel that there needs to be an open source wallet that somebody can actually look at all of the code. They can literally, you know, take it and fork it and create whatever they want from it. And also, we want a wallet that's modular so that different coins and projects can just plug into that, you know, same wallet. And, you know, there shouldn't just be like one entity building that whole wallet. It needs to be, you know, you build a framework for the wallet, and then different projects can plug into that wallet with, you know, interfaces to their networks. So there just isn't something out there like that right now. And we just want to create this because, you know, there's a need for it. So that's just something that we're doing on, you know, as an additional thing. And, you know, and I think it'll help projects that develop with Shardus, because when a project builds something with Shardus and creates their own coin, how are people going to access that coin? How are they going to interface with their network, right? So this Coinica wallet would provide, a basis and a framework for them to be able to plug an interface into Coinica that allows all the Coinica users to be able to quickly use this new network that they've launched. And so, yeah, so that's why we're building it. But it's kind of been a little bit on hold, because of our resources.
Great answer again, Omar. In response to that, your answer was, do we accept Flutter developers?
We haven't actually used Flutter, for building our front ends. But it's a possibility. I would encourage somebody to reach out to us, and we can discuss it.
Awesome. He said if we're hiring, he would gladly apply. So important to. We'll talk more about what a DAO is in a minute, and the difference between applying to a DAO versus a private entity. But Zachary Wiles' response and follow-up question to your answer on the Shardus IP strategy and licensing strategy was genius, maybe unprecedented. Thanks for explaining, Omar. So I think that brings up a good point. Is there any precedent for Shardus's licensing strategy or our intellectual property strategy?
So I think what we're doing with this model is something completely new. If you think about like how software has worked in the past, you had companies that build the software, and it may even be open source, meaning that you can look at the source, but it's it's built in a way and licensed where it's completely controlled by like the one company. And then you also have this other model where you have open source software where these developers are contributing to the software, but they don't almost get anything for doing that. I mean, the only thing they might get is like recognition and have their name on that project. Now, what's happened is that because we now have a world where we can create tokens and keep track of contributions to a project using tokens, we can have a hybrid model where it's not complete. You're not getting compensated for the efforts that you're making, and it's not something that it's completely controlled by one entity. So this is definitely a new kind of model that's possible only because of blockchain technology.
Awesome. Yeah, great response, Omar. There are a few other questions. For the purpose of people listening to this recording in the future, I just wanted to ask a few more technical focused questions as well. Amr, are you able to share your screen and bring back up the chart interface? Is that still up on your desktop?
I actually just closed it.
Okay.
Sorry about that.
No worries. No worries at all. Maybe I can share it on my screen. I took a screenshot of it. Just give me 1 second. I'm going to share my screen really quickly. Okay. So are you guys able to see that okay?
Mm-hmm.
Yep.
Okay. So Andrew, I'll ask this question to you since you have past experience as a game developer, and maybe a decentralized game is a future use case. I think we're seeing a lot of decentralized games being built currently. From an operations perspective, what types of metrics and data will be here that are important to a business? I think obviously the rejected transactions metric is important to understand user experience. If a lot of transactions are being rejected, then there's some user experience issues there. Are there other metrics on this chart that you think businesses will be looking at in the future? And also, what are some other important decentralized blockchain infrastructure related metrics you think businesses will be looking at?
Got it. I mean, as far as this chart here, this gives us just some critical information we need for development, and also helps us illustrate the linear scaling and the network growing and shrinking. And I mean, we're able to real quickly add more data to this. We have so much more data than this, but we don't want to like throw walls of data out in a presentation. But it's really essential for us to be able to develop a network when you have these tens of thousands of transactions flying around and nodes coming and going. But like one important number is like this internal nodes. I mean, watching that green line step lower and lower as the nodes grew is just showing that the network was becoming more capable given the same amount of load. We had a consistent load the whole time, but that load was less and less taxing on the network the whole time. And also, the rejected transactions, like it sounds like a bad thing, but really that's just a self-protection mechanism. So your network can, I think Omar talked about it. It can do what it can, but if it gets a little overloaded, it throws some transactions away, which is what we kind of contrived to purposefully put into this demo. We hit it with enough transactions that it would have to reject some and then scale up. Kind of related to games though, or any kind of online system, these changes happen over like long periods. Like there's like a 24-hour cycle that we'd see on graphs like this, where the users, ebb and flow depending on what country most of them are in, what time of day it is for them to be playing the game. I guess maybe one small point would be that like the actual like load of a network usually changes pretty slowly over time, and these kind of graphs are helpful for that.
Awesome, great response, Andrew. We do have 2 minutes left now, so I want to be respectful of everyone's time. I will ask 2 more questions. Omar, in 60 seconds, if you could answer, we talk a lot about decentralization and how Shardus is able to be truly decentralized in comparison to many other networks today. From a user perspective in the future, Shardus says our software can enable decentralized networks, but how will a user know if it's truly decentralized or not in comparison to maybe a different network that assigns node operators or administrators? How does someone on the front end truly understand if it's decentralized or not?
Yeah, that's a good question. And the funny thing about that is that from a user's perspective, it doesn't matter whether the network is decentralized or not. In fact, more centralized systems actually give a better user experience. Now, longer term though, when this starts to make a difference is when you have issues that happen that are kind of like black swan event type things, right? So for example, if you had a centralized system, if like all of that network was say being or that system was being run out of say one data center, and a hurricane was to hit that, you would see, this I can't access my service anymore. And so with a decentralized system, it provides much better, robust continuity of service. The other area is that with a centralized system or a federated system, you could have, state, governments like say China, like if they weren't happy with some account, they could go to these node operators and say, just ban that. And then, those, Bitcoin miners, for example, would probably comply. And so with a truly decentralized network, you're just not going to have that because, nobody knows who is actually running the nodes. So that's why it matters. But from a user experience, you won't notice it. But there are other things which will cause users to eventually say, like, oh, do I want to trust my money being on a centralized system, or do I want to trust it being on a decentralized system?
Great answer, Omar. Because we are on a live stream and anyone can leave at any time, I'll keep the questions going, and if you have time, you can stay. If the live stream ends because YouTube closes it, I apologize, but we get a lot of good questions here, so I'm going to keep firing them off. Shahzad, I'm going to put you on hold for 1 second. We got one more question that came in, and Amr, I'll ask you this question. Mohammed Ikram asked, great presentation. Can you describe an example or two as a business use case? So maybe talk about, decentralized use cases you see Shardus could be used for that you're most excited about. And you're on mute, so you just get, there you go.
Yeah. So some of the decentralized use cases that we've been talking about since like almost the very beginning is something like a decentralized eBay or like a decentralized Reddit. We use those models when we were coming up with what the interface should be for application developers, and thinking about like, okay, if I was to try to make like a decentralized eBay, for instance, I need like a database with all of my listings, and how should an application developer have access to that database when they try to like make a front end or something that lets users use this decentralized eBay? So there's a whole lot of like almost anything that you can think of that is an app can be done in like a decentralized way, because of the way we've designed like Shardus to be super general in that sense, where as long as you have like this concept of accounts and like accounts hold data, and if you design your application in that way, then it's able to be done in a decentralized way with Shardus. So lots of possibilities there.
Good response, Amr. I'm pretty entrepreneurial, so I like to think about blockchain use cases a lot as well. And I think one of the biggest challenges is we don't know what's going to be possible in 15 or 20 years. We can't foresee that far into the future and the impact this is going to have on the world. But one immediate use case I think a lot about is how our personal contact information has been sold for years and we've gotten no benefit or reward from it. If you think about the phone book and Yellow Pages, people have been taking our phone numbers and putting them into a book and selling that book to people for years, and that's our information that someone else is profiting off of. And now today there's a company called ZoomInfo that just went public, which is an enterprise B2B contact information database where all they do is get employees' names, title, email, and phone number, and then license out that database of information to all these other businesses who can then call you for sales purposes. And so, rather than having a middleman such as a phone book or someone like ZoomInfo with a database of all your contact information, imagine a global decentralized database where every time someone contacts you using your contact information, you're rewarded for your contact information being accessed, and there's no central authority having full control over all of that data. So it's really exciting to think about just all of the different possibilities and use cases for blockchain. And we're not psychics here at Shardus, so we can't foresee everything, but hopefully this helped paint a good picture on the possibilities of Shardus. Shahzad, I guess overall, what have we been doing for marketing this year, and what's the plan for marketing and Shardus growth for the remainder of 2021?
So, Greg, you and I have been talking to a lot of individuals and corporations, helping them, to decide on the use cases where Shardus could be utilized. We've also been building, partnerships across the board of organizations who could, use the product as well. In terms of marketing, we've been building a lot of grassroots level marketing efforts, focusing on academia. We've been talking to a lot of universities and the professors, trying to get them to help us, work with a lot of developers who can use the product, evaluate it, and give us some critical feedback before we get to the final launch. So that's been some of the efforts we have done. We've also been working on a brand ambassador program, which we intend to launch towards the third quarter and get it moving forward. Of course, the big bang would be as we get closer to the final launch of the product, where we really go to market with it. So I know you and I have been yearning to get our horses going, but we have another quarter or so before we really, pull that trigger.
Yeah, and I'd just like to kind of add to that in the sense that you know, I'd kind of like to think about Shardus as something like a database company, right? So when a company that's building software like a database, it doesn't just like go and start marketing before the software has been built and tested. And so that's kind of the view that we want to approach this from. Now, in the crypto and blockchain space, there's a lot of tendency for projects to start marketing themselves even like long before they've built anything. Like they just like put up a white paper and a website and say, this is what we're going to build and here's our token. And that's really why they're marketing themselves, is to sell their token, right? So we don't like to take that approach at all, but our token is there. If you feel that Shardus is doing something that could be used in the future, you can get the token if you want. Right. Thing. And so, but we are doing some effort in terms of helping to grow the awareness of Shardus and letting people know what we're building, so that if there's people that have ideas for a project that could be built using Shardus, they'll start looking at it and working with us. And and then also we mentioned working with academia to help make the final product better. So yeah.
Yes, and in the near future, Shardus will be looking for external auditors and related third parties to audit the Shardus code. So on the topic of opportunities to work with us, if you're skilled in security and you're watching this, I would encourage you to reach out to Omar. I guess one final question we will include before we wrap up is it was just about if we are running an ambassador program, or if we have any ambassadors we'd like to invite to the project. I would say we haven't truly formalized an ambassador program yet. However, we would like to grow that effort. Shardus, is there anything you wanted to add there regarding the ambassador program? Shazad?
No, like you mentioned, Greg, I mean, we do have a program in place. It's just a question of, starting to execute that. And hopefully even in the next quarter, we'll have a formalized, launch of that as well. Greg, there was another question I'd like Omar to answer, was regarding any plans to migrate on BSC.
Oh yeah. Okay, so in fact, we did have our Shardus token, which is a smart contract on Ethereum. We did have a bridge to BSC, but that bridge was being created by a swap service called Burger Swap. And we decided that that was not very decentralized, and it kind of depended too much on Burger Swap being there. So we kind of, the bridge is still there. If you want, you could use it, but we don't really, recommend that route. Now, what's happened recently is the Matic or Polygon project has created and launched their network, and they have a much more decentralized bridge between Ethereum and the Matic network. And so we've contacted the Matic team, and they now recognize the Shardus token ULT and have done the mapping so that you can now transfer your Shardus tokens from the Ethereum network over to the Matic network and then use them over there. And then you could also transfer them back to the Ethereum network whenever you wanted. And that's using the, I don't know if they're, well, it's kind of like based on plasma technology, but Matic's like advanced version of plasma technology, which makes that transfer happen a lot faster than say like 7 days. And so, you know, that's a much more decentralized bridge, and it's available now, and we're going to start using that. I mean, it just became available this past month, and we're going to start, you know, making that possible. And there's swap services on the Matic network as well, which, you know, people would be able to convert their ULTs into, you know, other things, or use, you know, Ethereum or DAI and things like that to buy ULT. And the fees on the Matic network are extremely low, like fractions of a penny. So I think people will find that, you know, like a huge benefit, because like, you know, compared to like the, you know, $50 or $100 transactions fees that we've seen on the Ethereum network. So.
Awesome. Well, great job, team. That's all the questions for today. It looks like we had people joining from all around the world. Someone said they were checking in from Hong Kong, one from Russia. You know, based on some of the questions, it seems like we had some fluent native English speakers here as well. So excited to see community members joining from all around the world, and we'll look forward to our next quarterly update presentation. As mentioned, in the meantime, if you're looking for opportunities to get involved, you can email Omar at shardus.com, or myself, Greg, at shardus.com. Would also please encourage you to follow our social media channels. I shared the Linktree link in the chat area for you to view our different social media profiles. And if you'd like to promote Shardus, please share it with your friends. Thank you all so much for your time, and hope you have a great day.
Thank you.
Take care.